In previous video, we saw step-by-step process on integrating Gemini AI in Azure API management. In this video, we will see how Gemini AI can be rate limited in terms of the token consumption using API management. This way, it can help us to limit AI cost spikes as well. Hello and welcome all to my YouTube channel Azure Beyond Demos. My name is Kunal Chandratre and let us just start on rate limiting Gemini using API management. This is obvious question. Google Gemini already has a rate limit. Then why do I need API management to do the rate limiting? Let's understand. This is my Google AI Studio. If I go to dashboard, usage and billing, you will see an option of rate limit. So if there is already rate limit available, then why do I need API management? Well, the rate limit for Gemini you see on my screen is applied at the entire project level. This rate limit is common for multiple client application consuming the same AI model deployment in a single project. Means this rate limit is applied at the project level and not at individual client level who are consuming the model. So if I want to have rate limit per consuming client, then it is not available in Google AI Studio, and that is why we need API management. Let's understand more with an Imagine your company has two chatbot applications that uses Gemini AI behind the scene. One is let's say support bot and let's say another is the fun bot. Now support bot is really critical bot used by your premium customers for urgent support request. So this is really an important bot for us. Okay. Fun bot, a non-critical bot used for casual queries uh, and let's say general engagement. Okay. So it is not very important. Okay. Now, let's say both these chatbot applications call Google Gemini AI through Azure API management. Now, here is the problem. Funbot suddenly becomes very popular and starts sending huge number of requests to Gemini AI. Because Gemini has limited throughput, Funbot's traffic consumes most of the quota. And as a result, support bot starts failing and it requests time out or get rejected, even though it is a more important bot. So to avoid this, we introduce rate limiting in Azure API management. Okay. So in this case, we will assign higher rate limit to support bot, let's say 200 tokens per minute. Whereas for fun bot, we assign the lower limits, let's say 50 TPM. Okay. Now what happens? Even if the fun bot sends massive traffic, it automatically gets throttled by API management. And support bot always gets the enough capacity to call Gemini smoothly. So Gemini is protected from the overload and critical business workloads stay. We will implement the rate limiting in two ways. In first approach, we will configure common limit across all clients. Say we set up the limit of 200 TPM and all consuming clients will get the same limit. In the second approach, we will assign separate rate limit per consuming client, just like FunBot and SupportBot example I gave. Let's understand the implementation logic. Okay. So what is our purpose? So the basic idea is to estimate how many tokens your request will consume. Okay. And for that, we will be using Gemini's count tokens API. And then we will enforce the per minute or per hour token budgets before forwarding the call. So who it limits? Basically, it groups the usage per subscriber. Okay, using subscription ID, preferring the API management subscription ID. Otherwise, whatever the header that subscription has, and if none of these is present, then it will fall back to the client IP. Okay, then how does it actually estimates? It extracts the model name from URL calls. Uh, then it actually builds the count token API call with the body and reads the token count from that response. That is how the token estimation is done. And then how do we enforce the budget? We enforce the budget per minute, let's say 200 tokens per hour, 2000 tokens via rolling counters, and it is configurable. In this example, I'm using these values. Okay. If the new request would push you over a minute budget, it returns the 429, a short JSON error of rate limit. If it would push you over the hour budget, then it returns 429 with JSON error where we are hitting the hourly limit. Okay. Then how exactly the counters are stored? It keeps a minute hour counters in API management cache keyed against the subscriber plus time window, and then it updates them after each request. That is how we are maintaining the count. Then what goes to the backend? It restores the original request body. It adds the key, which is Google API key, as a query parameter from API management named value, and then forwards that call if at all it is within the limits. And at the end, you get the error 429 response, which includes a friendly JSON message, and the content type of that error will be application JSON. Hope this clarifies. Now let's look at the actual policy code. So here we are setting up the common limits for per hour per minute and the window. Then we are checking if there is a subscription ID present or subscription key header is present. And if nothing is present, then we fall back to the incoming request IP address. Then we are using this code to build the URL. This URL we will use to call the count token API call. Okay, and this is where I'm using the named value where Google API key is stored. Now, when this particular code is executed via send request, we actually receive the response which has the uh, token count. That token count is calculated and parsed and stored in this code via this variable. So this is the variable which will have the token count. Then whatever the token count and everything calculation is done, all of this information is actually stored into the inbuilt cache of API management via this code. Okay. After that, we check the conditions. So in this condition, per minute, we are checking if the value is being crossed for the limit that we have set in this variable, tokens per limit. If the limit is breached, we send the 429 error. Similarly, per hour calculation is also done. And if we breach the per hour limit, then also the 429 error is sent. Let's run the client, and this is my code to test the rate limiting of Gemini. So the current policy that I explained you is related to common limit for all clients. So we will test that first. So what I'm doing here is I'm actually specifying my model name, my API gateway URL, and I'm actually trying to run approximately overall 10 runs with this much of the delay. Okay. And then basically I pass on this particular content which is payload, and then the rest of the code is used basically just to represent the output. So I'll not go into that, it's very straightforward. Now let's try to run this. Okay, the run is complete. I am using the free tier of Google AI. So you can see that my first run was successful. The second run I faced an error as model is overloaded, but it did not turn into 429. After that, up to the run number 7, everything went well. Then on run number 8, I started facing 429 error, which actually exceeded my per minute limit. Okay, so that is how this default rate limiting can work. Now let's look at the policy related to per client. Policy rate limit per subscription ID is not very different from the common rate limiting policy we have seen. The major difference is this choose block. This is where you will actually add all your number of clients and their associated subscription keys. And then for each client, you will put the specific rate limiting that you want to achieve. For example, over here, for the client one, I am putting the per limit and per hour token rate limiting as 50 and 100. And let's say my client 2 is very critical for me. So I have almost kept 10x of the token limit for this particular client. Now, important thing over here is we need to replace this subscription key by the actual subscription key. So that you can find over here. Go to your API management subscriptions. I will be using client one and then client two subscription key that is visible over here. Okay. All right. Let's copy paste and then let's run the client. The client testing code is simple. So these are the two client codes. Okay. In both the clients, I'm using same model as you can see. The client one is not so important client. I'm going to run 10 iterations, and then client 2 is important. Here also I'm going to do the 10 iterations. But the limit that we have put on the API management policy is different. It's pretty low for the client 1, and for client 2 it is higher. Okay, then I have two PowerShell windows. Here I'm going to run the client 1, and this is another PowerShell window. Here I'm going to run the client 2. All right, the run is complete, and as you can see, for client one, only one call was successful. The rest, all of them went into quota exceeded error. Now, if you look at the important client, which is client two, and you can see that all my 10 calls went perfectly fine, and there was no quota error. So this demonstrates how exactly the rate limiting for Gemini using API management per client. All right. So all the code base of policy and client testing is added into my GitHub, and the GitHub URL is added into the description box. So you can do the copy pasting from that URL. Now to the next part where I received a lot of queries from you, and I call this section as real world questions not easily answered. Thank you for sending your questions on LinkedIn and on YouTube. Now let's take one by one. So the first question is about, is this rate limiting applied on inbound and outbound both? So the question here is whether this rate limit is applied on the inbound request tokens or outbound request tokens. So if you observe the code base on my GitHub, you will see that I added this policy construct in inbound section. So token calculation is applied on the inbound only. If you want it on outbound token calculation on the response, then you will have to write similar policy for outbound section in API management. Point number two, can I use external cache store for storing the token calculation? Yes, you can use Azure Redis cache, or now it is called as Azure Managed Redis, the new offering. You can use that, or you can use any external cache if needed. Point number three, how can I log which client app use how many tokens with Gemini AI? In my opinion, this is not Gemini AI, but API management functionality. On Azure API management, you can write a policy to capture the logs and token count in Azure Application Insight. I have really not tried this, and as of today, no customer has asked me yet. So as of now, I'm not doing it. But I think it should be easy to log to App Insights and show the information of tokens using KQL query in Application Insights. Okay, now let's go to point number four. What happens when quota limit for application is crossed, and what should I do with it? So whenever the quota is hit, the API management will return either 429 or 403, and you should implement retry logic, and it should be handled on the client side. There is nothing you can do on the Gemini side or API management side. Please understand this. Question number five, can we apply rate limits per IP, per user, or per subscription? Not per user, honestly, but definitely per subscription or incoming IP. And this is what I demonstrated in the video. Then point number six, will API management itself cost more if traffic is high? It's funny question. So as long as you are using non-consumption tier of API management, your cost is going to remain fixed for API management. Example, basic, standard, and premium tiers have fixed cost and they do not increase based on the traffic. Of course, there is a certain throughput limit on how much traffic can be served by single instance of API management. And to go beyond that throughput limit, you can use auto scale or use more number of API management instances. All right. I hope this particular video have given you a wonderful and amazing idea of how the rate limitation